Welcome to your lecture on organic functional groups. My recommendation is that you have a pencil or pen and paper so that you can write down structural formulas. You can write down questions for clarification and understanding. Hopefully we'll answer those questions by the end of this lecture. But if we don't, please make sure that you see your instructor before you take the assessment and get those questions answered. Okay? Today, we are going to be looking at carboxylic acids and esters. And this one you're going to have to really pay attention to because carboxylic acid, unlike your aldehydes and your ketones, your ethers, and even some of your alcohols, there will be charms present on here. So make sure you're paying apt attention. So when we look at the structure of our carboxylic acid and our esters, here we see that carboxylic acids occur only at the ends of a chain, which is good news. The charms themselves, just want to write this a little better, okay, are double bonded O and an OH. So here, only at the ends of the chain. This time, we have a double bonded O and you have an OH. Now that's different because if you remember when we looked at aldehyde, we had a double bonded O that ended in hydrogen. This time we're actually adding two charms. The charm is double bond O and OH at the ends, and it is only at the ends where you find them. So you'll either see it look like this, or you might see a carbon with a double bonded O, OH here, the rest of the chain, and then the final carbon on this side with a double bonded O and an OH. And then you have the ester. The ester actually splits the chain with a double bonded O. So here is a double bonded O on the end of a carbon chain, and then this oxygen splits it, and then there's the rest of the chain. So how would I name something like that? Well, just like before, we know that when an oxygen splits a chain, it becomes a charm and a charm. In this case, we have an entire chain on this side. Then the oxygen is splitting a chain, the rest of the chain, and then you have this, which now, instead of being a chain, actually is going to become a charm. And we'll get into that when we get to naming that. Okay? So, let's go ahead and get started with the carboxylic acid, but pay close attention to how we go about putting the carboxylic acid and naming the carboxylic acid together. Remember, there are two charms that are going on them. One is a double bonded O, and one is the OH bond. And it is only on the ends of the carbon chain. So, how do we name them? Well, name is the last name, main chain, but you need to know the prefix for the number of carbons in the chain. Make sure you know the type of bond, whether it is an ane, ene, or ine. And look at the ends. The ends of the name, in this case, are going to be oic acid if there's one charm, dioic acid if it's on both ends. So remember to keep that rule about carboxylic acid. So let's see, and we're going to go kind of slow with this one, just to make sure we know all the parts and the parameters of it, okay? Okay. Here's the carboxylic acid. Kind of looks daunting, doesn't it? But don't let that throw you. There is your carboxylic charm. There is the double bonded O, and here you have the OH attached to the carbon end. Now, because this is the end of the carbon, and this is where your charm has priority, because it's closest to the end, this is going to be carbon 1, 2, 3, 4, 5, 6, 7, 8. The rest of your rules go naturally when it talks about charms. Well, here's a charm, bromo, and here's a charm, propyl. Who goes first? Bromo does. Where's bromo located? On carbon 4. So that is 4 bromo, 2 propyl, and carbon 1 is automatic because that's where the carboxyl charm is. So this is an 8 carbon compound, which is oct. It is a single bond, so it's octane. Now, what have we been doing about the E? Well, we said if there's only one, we've been getting rid of that E. And then we said this ends in oic acid. Now notice its name. It's not just one name, al, ol. It's oic and acid. These two have got to be together in order to name that. Okay? Got to be together in order to name that. Notice that unlike the other charms, instead of there being one charm that denotes that this is a functional group, this has two charms, the double bonded O and the OH. And notice again, look at where the OH is. Remember, hydrogen only has one bond. Oxygen has two. So on this side, it would be HO carbon. But on this side, if I were putting another one, it would be OH and the double bonded carbon. Because oxygen has two sites for bonding. Remember that. Okay, so let's see if we got this called right. Gotta give a second for that bottom to drop away. Dropping the E from the alkyne name, adding oic acid, 4 bromo, 2 propyl, octane oic acid. If we got this right, so if you understood how it was deconstructed, in order to get this name, you're doing just fine. Let's look at another one. Here we go. So, first question is, where are your carboxyl acids? Well, you have a double bond O and an OH on this carbon end. You have a double bond O and an OH on this carbon end. So you've got 2 carboxylic acids. So where is carbon 1? Well, carbon 1 is where the carboxylic acid is. I've got 2. How do I judge? Well, I look to see where my charms are. I have a charm of chlorine, 3 carbons in. I have a charm of ethyl, 3 carbons in. And then I have a charm of ethyl on the 4th carbon. So this is what I'm going to call charm heavy. Charm heavy. So whereas charm heavy, I'm going to make that carbon number 1. So I'm going to say that my carbon number 1 is right here. 1, 2, 3, 4, 5, 6, 7, 8. Now, does that mean that Hudson is right? No, it doesn't. It means that I put that as my carbon 1 because I'm looking at the priority and where it's charm heavy. So let's see if we're doing it my way. How am I naming this? Well, now I got to look at my charms. I've got an ethyl here, I've got an alpha here, and I've got a chloral here. Well, in order, chloral comes before ethyl, so I would have 6 chloro. Then I would have 3, 4 diethyl. And then I'd have an 8 carbon, which is oct, single bond, which is ane. There's more than one carboxylic acid. And since I get rid of the E, if it's a 1 carboxylic acid, I guess I'm going to leave the E here. There are 2 carboxylic acid, so I'm going to put di. And the ending for carboxylic acid is oic and acid. So I have 6 chloral, 3, 4 diethyl, octane dioic acid. All right, so let's see how good we are, or how good Dr. Hudson is anyway. 6-chloro, 3,4-diethyl octane dioic acid. Yay! If you were able to follow along with me with this, you're doing just fine. All right, let's look at another one. This one. I'm going to let you go ahead and see if you can do it yourself. Pause the video, do it yourself, and then come back and check. Okay? All right, so the answer to this is 5-chloro, 4-ethyl heptanoic acid. Let's deconstruct this, shall we? All right, where is carbon number 1? Well, the carboxylic acid is closest to the end because there's only one. So this is carbon 1, 2, 3, 4, 5, 6, and 7. When I look at my charms, I have a chloro charm and an ethyl charm. So chloro comes before ethyl, 5-chloro. Ethyl's on carbon 4, 4-ethyl. Heptane, but there's only one, so I'm going to take off the E, so it's going to be heptan. And then this is oic and acid. If you got what I got, you're doing just fine. Pause this. Okay, so look at this one. See if you can figure this one out. Careful. There's a C in there that you might not think is a C, but it's there. Pause the video if you need to and then come back to it. This is called, give me a second. Oops. There we go. 2-methyl pentane dioic acid. Now let's look at this. All right, so where's carbon 1? Well, there's a carboxylic acid on both ends. So we look at the one that's got more charms. Well, this carbon, there's a carbon. It's in black. It's not part of the chain, but it is a carbon, and that's a methyl. So this is going to be carbon 1, 2, 3, 4, 5. Remember I told you be careful of the carbons. All right, so this is 2-methyl, right? And then there are 5 carbons, so that's pentane. Since there are 2 carboxylic acids, we're going to leave the E, and then it's going to be di because there's 2, oic acid. Okay, let's look at another one. Best way to do it is just keep doing them. Try and see if you can name this one. Pause the video if you need to, and then play to check yourself. This is 8-iodo 7-methyl octanoic acid. Okay, well, let's see. Why is that 8-iodo? Well, when we look at our ends, there is a charm on the end of carbon, and there is, of course, the functional group, and then there is a charm. So this is pretty much right here was what we would call charm heavy. How be the ever? This is the functional group. And the functional group has priority. And because this functional group is on the end of that carbon, then that is going to make this carbon number 1, 2, 3, 4, 5, 6, 7, 8. Now we look at the charms of iodo and methyl. Iodo's on carbon 8, 8-iodo. Methyl's on carbon 7, 7-methyl. 8-carbon compound because there's only a carbon chain because there's only one carboxylic acid. That E goes away, and then it's oic acid. Look at that carefully. Make sure you understand that. The functional group does get priority in something like that, so be very careful when you're naming those. See if you can name this one. Pause. Press play when you're ready. Okay, this is 3,9-dibromo 4,7-diethyl 2-methyl nonanoic acid. So let's deconstruct this. Your carboxylic acid is located here. And yes, you have a you have a charm here. However, not only is your carboxylic acid located here, this is also charm heavy. But more importantly, the carboxylic acid is the functional group. And it has priority. Remember, we just talked about that. Okay? So, this is carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. So, on carbon 9 and carbon 3, you have 2 bromos, so that's 3,9-dibromo. On carbon 4 and 7, you have 2 ethyls, so that's 4,7-diethyl. On carbon 2, you have a methyl, so that's 2-methyl. These are 9 carbons, which is non-named, but there's only one carboxylic acid, so we get rid of the E, and that's oic acid. If you got this correct, you're doing just fine. If you're still having difficulty, continue to practice. Here's one. This should be easy for you. Go ahead and see if you can get this one. And let me see what the answer to that is. Propane dioic acid. Here we go. Propane dioic acid. All right, since they got carboxylic acids on either side, it doesn't matter which one is number 1. So we'll just call this 1, 2, 3. Propane, because it's a 3-carbon. And we leave the E because there's more than one carboxylic acid. There are 2, which is the dioic and the acid. Okay, so now we're going to look at the ester. Remember, the ester has a double bonded O, and there's an oxygen that breaks the chain. Remember, an oxygen breaks the chain, and when it breaks the chain, it causes that other half to now be a charm. Now, the side where the double bonded oxygen is, this is still going to be the chain, but where that break is, that is going to be the charm. Okay, and we'll, like I said, you got to pay really close attention to this, okay? All right, so what do we do with this one? Well, we look at the part after the break in the chain, and it is named like a charm. And based on the number of carbons, we use the prefix, and it ends in YL or il. Propyl, butyl. We need the prefix for the number of carbons in the chain, and then it ends in O8 for the name of the chain. Okay, so keep these rules in mind. Let's look at the first one. Okay, here you have your functional group. This is the ester charm. Now, just like the carboxylic acid, there are 2 charms involved. There's that double bonded O, and then there's that single O, but that O, remember, breaks that, and the other side of that O now becomes the charm. The side with the double bond O is part of the chain. So when we look at this, we name it like we always do, charm and then chain. This charm is butyl because there are 4 carbons, 1, 2, 3, 4. The other side has, we'll call this carbon 1 if you want to, 2, 3 carbons. So this is propane. We take the E off because we always do if there's only one, right? Propane, not propane. Propane, O8. That's that ending. All right, so let's check and see if we got it right. Butyl propane O8. Okay, and that's how you do them all. Wherever you see the break of the oxygen, this is the charm. And where you see the double bond oxygen, this is the chain. All right, using that pattern, let's look at some more. Look at this one. The break is here. There's 1, 2, 3, 4, 5, 6. That's a 6-carbon charm, which is hexyl. And then here is your chain. This is FN, because there's only one, O8. Okay, let's see if we got that right. Hexyl ethane O8. If you got this right, you're doing great. You're doing great. Let's look at this one. Now be careful. Be careful. Remember, double bond is where the chain is. The O is where the charm is. So if we look at this one carefully, we find the oxygen is cutting here. So this then is my charm. And this then with the double bond is my chain. There's only one carbon, so this is methyl. And my chain is 1, 2, 3, 4, 5, 6, 7. So that would be heptanoate. And let's check ourselves to see if we got it right. Methylheptanoate. Okay. Do this one by yourself. Pause the video and then come back and press play. Ethyl butanoate. Let's see why. Here's my cut, because that is the oxygen that breaks up my chain. This is the charm, ethyl. And then here is my chain, 4-carbon chain, which is butane. And it ends in OATE, which is ethyl butanoate. If you got the same thing I got, you're doing a great job. And that is the end of this lecture.